In this video we will learn about interesting phenomenon of army and swarm rate, and we will explain the relations to the complex systems. But before we focus on the rates themselves, let's have a quick introduction to the army ant species. Army ants is not a name of just single ant species, but of several hundred. All of them share common ancestor, which lived 100 millions of years ago, not long before continents split up. Nowadays we can find two families of them. First called Doryline, you can find them in Africa. Second one is living in America and is called Ecitonine. Being named as army ants wasn't a random choice. When they set off to hunt for food, they do so in great numbers, marching onwards like a real army, wreaking havoc among everything that crosses their path, be it other social insects, spiders, scorpions, or occasionally even larger mammals like sheep and cows. They've got fully adjusted to their lifestyle, which is nomadic. They continuously shift between two phases. First is migration phase, during which they move from one place to another every day, and stationary phase, during which they stay in one place for several days so that the queen can lay new eggs. This way of life causes problems with nesting. Many other ant species, in order to protect their queen and brood, build their nest underground. However, army ants don't have time to build proper nest every time they move, but they still need to protect their queen somehow. Their solution is both simple and sophisticated. At the end of the day, they build a living structure called bivouac. It is composed from more than 500,000 of female workers and it's well organized. In the middle is the queen, the younger workers form the interior, the older ones form the exterior, and the largest, the majors, are patrolling on top of them. Now let's have a closer look at the raid itself. It begins at dawn, when the bivouac dissolves and the trail starts forming up. After it is formed, it will last for another 10 hours. It can be 100 meters long, 15 meters wide, and it will sweep over the area of more than 1500 square meters. We distinguish two main parts of the swarm raid. First is swarm front, and the second is principal column. Each of them has its own purpose. The white front provides mass of ants that will quickly overcome any enemy before it can inflict any serious casualties. On the other hand, principal column is easier to follow and to protect from sight. Now let's have a look what's going on within the raid. The swarm front follows so-called rebound pattern. The workers on the top move few centimeters ahead, then assess the situation and returns back to the front. According to their findings, they can decide to change the direction of the raid or even split the front in more streams. It causes the raid to move very slowly as a whole, just 2 centimeters per minute, even though the ants in the principal column can move as fast as 3 meters in average. The number of ants in the raid isn't constant. Usually it's 200,000, but it changes every time. It depends on actual success of the raid and on the process we call the regulated recruitment. If there are lots of workers returning to the bivouac with food, it means the source of food was plentiful and there is no need to send additional workers to help them. However, if there is only few workers returning with food or they are returning empty-handed, it means there is either difficult enemy to overcome or they need to cover larger area. In this case, additional workers will join the raid. Another important aspect of the swarm raid is trail formation. It is influenced by two major factors. The first of them are the pheromone trails. The army ants are completely blind, so they have to rely on other senses. The second one is food distribution. Their effect is illustrated on following computer models. First case shows situation when there is no food along the way. The swarm just continues forward. The white dots represent places with highest concentrations of ants, the blue ones the lowest. You can see most of the ants are following the same path. That's because the pheromone trails are strongest here. The second case shows what happens if the food items are distributed evenly along the way. The swarm front remains, but the primary column is now divided in several branches. As you can see, the rate is very dynamic, but the general pattern remained still stable. Now that we introduced some details about army ants and swarm rate, let's have a look at their connection to complex systems. As you may know, complex system is a system composed of many interconnected parts that as a whole exhibit one or more properties not obvious from the properties of individual parts. Each complex system should have following features. First, it is difficult to determine its boundaries. That means we can see them from different perspectives and in various contexts. For example, at the lowest level, we will see individual ants, each of them having assigned its specific role. Miners and media are the smallest ones, and also carry smallest prey. Submajors are the fastest runners and used to transport large prey. Majors are the strongest ones and pose the role of guardians. Finally, there is the queen, whose single purpose is to lay new eggs. If we move one level higher, we will get to the group level. Here we will notice that there is no individual leadership and no planning in advance. Ants respond immediately to their surroundings, and they do so in a collective manner. We can move even higher and look at the rates from the global perspective and observe their impact on the environment. It may seem that the rates have only devastative effect. This is not exactly true. For example, they are sought out by farmers because they help to get rid of the snakes, mice, scorpions and other pests. They can also serve as a food source. Some animals hunt either them or the prey they carry. Each complex system is feedback driven and self-organized. In this case, we mentioned that the path of the rate is altered by pheromone trails and food distribution. With the contact between ants in the raid and bivouac, they can adjust numbers of workers participating in the raid according to their current needs. Another feature of the complex systems is the non-linearity. It means that even with same starting condition, no two swarm rates will ever be identical. Even small perturbation can greatly affect the state of the raid. And lastly, complex systems shows some kind of emergent behavior. It is a behavior which will not become apparent unless we shift from the focus on parts to the focus on the system as a whole. For example, from simple rules like blind follows blind, emerges stable swarm rate pattern. It is a well-known fact that social insect colonies are complex systems. But as we learned in the last couple of minutes, we can perceive a specific phenomenon such as army and swarm rates as a complex system as well. And that's all. Thank you for your attention and I hope you enjoyed it.